In the previous segment, we saw the second very important step of checking whether we have reached our target after every step. Then the third important thing is to keep a count of how many steps you have moved forward. Okay, that's very important because if you lose track of how many steps you have taken, you will lose many information. Okay, so make it a habit to keep a count of that. Okay, so that's I call keep a count of steps taken, right? So whatever you are doing, so you always try to keep a count. Now that brings to one more important what do you call concept of programmatic thinking, and that is where to keep all these things, because now like buckets, if you have buckets at your home, you can't just keep on using a new utensil for another dish, okay, a new dish every time. You have to reuse those utensils or buckets, okay, I'll call buckets. And then that type of thing is also important in programmatic thinking, that suppose you are adding a number, for example, in again if I go back to our previous thing, you were it's like doing an operation. This addition operation is like putting those things in the bucket, and that bucket size keeps on increasing, right? So first you put there 1, okay, as soon as you encountered 1, you put it there, and then when you saw 2, you knew what to do, so you also put 2 there. So now the number of objects in the bucket have become 3, and then to this 3 you added another 3 objects like that. So you kept on adding to the same bucket, right? Now, but now see, you have to also keep a count of things, that how many steps you have taken. How will you do that? So if you think in terms of buckets, because programming is all about thinking in terms of buckets. Now as soon as you take a step, for example, as soon as you did this step once, so you added, right? So once you added the smaller step which you were aware of, addition was the thing which you knew, right? So that means as soon as you did that operation, so that's called one step. So you will put say 1 ball there, so that later on you can count it. And as soon as you did the second operation, as soon as you, so when you put this 1 and 2, and you just told that okay, 1 operation is done, 1 ball. As soon as you put the third number 3 there, so you have to put another ball there to keep a count. So now you see, to keep a count, you have to have another bucket. You can't use the same bucket to do that, right? And yeah, that's it. So I think for this problem you will require only these 2 buckets, and here after every step the checking which you are performing, actually you are doing on this. You are looking how many balls are there. As soon as you know that there are 99, so the checking could have been done in 2 ways. You are seeing that whatever you are bringing, now that bringing thing, maybe it's a very large pool of numbers where it's the set of natural numbers, okay. So it is a set of natural number from where you are picking these numbers. So that was anyway there with you, so you didn't require in a way a bucket for that. This big bucket was available to you. And now so to see that whether you have reached the target, that checking point, you could have done by checking the number which you are bringing. Okay, so from this you are bringing one number, so that you could have checked whether it is the what do I call, the target has been reached. It is the maximum number which I was supposed to add. So that you can check, or else you can check here that whether I have performed. See, here you have to perform how many? 99 such operations, right? So if you are counting the number of operations that you are making, so you have to count these balls and see that okay, 99 balls are there in the bucket, and then I have to stop. So that is the kind of thought process which goes into every programming, whatever you think of. Okay, so this is the most basic building block of any program which you will write at any point of life, point in your life. Okay, so yeah, so now thinking about these number of buckets which are required. For example, if I go to this example when we were having this 10 to 2 division. Now, so initially there was a bucket, maybe. Okay, let me do there. So for the second problem, initially you had a bucket in which there were 10. So you took 2 out, and so that 2 you can throw to this big number basket, which you don't have to care about because it's available to all. Then again you have to have maybe here, it's not required now to calculate the number of steps is required, because that will be the final thing which you are looking for. The answer is the number of balls which you are putting there, right? So as soon as you move that, so you put a ball there, but to put that ball you need another bucket, otherwise where you will have this counting. So you can think that you are keeping a count of that step, and that itself will give you the answer in this case. Okay, in this case, in the first problem, the if you just count whatever is available in this bucket was the answer, and in this case when you count whatever is available in this number of balls, in that is your answer. So that's what is your job to look for in which problem what bucket needs to be seen, and then which will give you the final answer. So then in all problem, believe me, in any complex problem which you can think of, this is the only thing which is done in any programming. Okay, so you put 2 there, so again you checked. So now the checking was done on this bucket now, whether this bucket is empty or not. Okay, so then you put another 2, so like that, so you put another ball there. So that's how you did. So again you require 2 buckets. Now when we discuss more difficult problems with examples, and then we will do all steps, okay, one by one steps, because we said that we will do it from scratch, and then you will see that in some problems you will require more number of buckets. Only 2 buckets will not be sufficient. In fact, now I can formally tell you some names which will be used in programming language for these stuffs which I discussed now. These buckets will be called variables. The steps which we take, repetitive steps, will be called looping, and the counts which you keep, they also so they are like variables only, buckets. So and the checking which you make, they will be called conditional statements. So these are big terms, but who cares? Okay, we have to just think in terms of these basic things. What are the things which we are doing now for programming? Look for repetitive steps, look for when to stop and what to be seen, so that we will know that when to stop. Keep a count and look for how many least number of buckets will be sufficient to keep things, so that finally we are done. So that's about the basic thought process, and we will see some examples in terms of these kind of thinking in the next segments to come. See you in the next segment.